Thanks for coming. Again, I'm Cynthia Dittbrenner, Director of Coast and Natural Resources at the Trustees. I have been here a short 6 months, so still feeling my way around here and getting to know people. So I would love to meet you. If you have any questions or want to chat about what I present, please reach out. I have 20-something odd year career in natural resources. A lot of that was doing salmon recovery on the West Coast, rivers and stream restoration. Experience doing climate resiliency with agriculture in the floodplains, and then more recently at the Trustees, now working on the coast, but also leading a team of ecologists who manage the ecological health of our reservations across the state. So excited to be one of 3 speakers today. We have Russ Hopping, who's our lead coastal ecologist with the Trustees, and then Danielle Perry from Mass Audubon, who's the Coastal Resilience Program Director. Our talk today is how sea level rise is affecting our coastal salt marshes and what we can do about it. So for those of you who don't know the Trustees, we are the oldest land conservation organization in the country, founded in 1891, celebrating a 128-year legacy. We signed on a few new properties this year, bringing the total to 123 reservations. This map shows our coastal reservations. We protect and steward over 120 miles of Massachusetts coastline. Let me go back to this other slide. So about 5 years ago, we launched a climate vulnerability assessment for our coastal properties. We were seeing a lot of changes and we wanted to know the impact of sea level rise and storm surge on our properties. And the report was very illuminating. It showed impacts to infrastructure and habitat. And so that prompted us to initiate a larger coastal strategy across the organization. There are 3 tenets for that: protect the coastal resources and advocate for them. Number 2 is inspire a love of coast. So that gets to the root of our mission, which is engaging the public in natural resources. And then number 3, which is what I'm going to talk about today, which is focus on our most vulnerable places. What are the impacts to the habitat and the communities, and what can we do about it? Part of that coastal strategy was we decided let's do a state of the coast report and cover all 5 regions of the coast on the state. 1 report each year over 5 years. So we're a few into that. The first year was the one on the left. In 2020, we launched State of the Coast report for the North Shore. A lot of the information I'm going to share today is from that. And then last year, we launched one for the islands, Martha's Vineyard, Nantucket, and Gosnell. So just to set the stage, what we're facing, we looked again at the impacts of sea level rise and storm surge specifically on our coasts. The graph to the left shows sea level rise. Green shows sea level rise we've experienced to date. And then to the right are 4 diverging dotted lines showing different scenarios. These are based on different greenhouse gas emission scenarios. People are generally thinking that the extreme one, the red one, may be higher than we'll expect. The new NOAA report came out a few weeks and said it as much. We have been planning to the high scenario, which is that dotted orange line. It'd be nice to be on a lower one, but just so you know, the maps I'm going to show you are that high scenario, which hopefully is the worst case scenario, but we won't know. That's the track we're actually on right now. And then on the right, we've got storm surge or flood surge levels. The lighter orange is a 1 in 10 year storm, so a probability of having this about once every 10 years, and the darker is the 1 in 100. One thing I like to point out on this is that for the historic, the 1 in 100 year storm right now, once in a lifetime storm, is going to be about a 10-year storm by 2050. So we'll start seeing these bigger storms much more frequently. Our focus today is on salt marshes. Now, those reports that I mentioned, we looked at the impacts of flooding. So we pulled in some flood modeling from the state and did some assessment of infrastructure impacts. But we also looked at the impact to habitat. And we're focusing today on salt marshes. Why are salt marshes important? A lot of you probably already know this. They provide immense protection from floods for our coastal communities, a huge sponge and protector along our coast from those big waves. They provide incredible habitat for wildlife, and Russ and Danielle will talk a little bit more about that. They filter pollutants, improve water quality, and then they also store an incredible amount of carbon. It depends on which research study you look at in comparison to forests, but I've heard 10 times more carbon than forests, up to 50. So the question of the hour is, can salt marshes keep up with sea level rise? They naturally accrete and build an elevation over time with both sediment and organic matter. Can it keep up with sea level rise? This graph depicts that. The blue is sea level rise, and then the darker green is about what we're seeing right now as far as accretion of the marshes. So there'll be a point in the future, this little orange circle, where marshes will get inundated with water. They won't be able to keep up. So what we are going to present on today is different techniques of restoration to help heal the hydrology that we have messed up over the years, to allow the marshes to accrete more rapidly, hopefully on this lighter green line up here, to keep pace with sea level rise. My credit to this modeling efforts down here in the lower right, this is a CZM SLAM viewer. So SLAM modeling is sea level affecting marsh migration. And this was modeling work done by Coastal Zone Management at Massachusetts here. And so we pulled in that data. That's what I'm going to be showing you a few maps of today. This is some salt marsh out on Pocha Pond in Martha's Vineyard. Excuse me. So if you don't know, we make a distinction in the habitat world between high marsh and low marsh. High marsh is shown here in this kind of lightish green color, and it is marsh that is inundated once, maybe twice a month with the lunar cycle. Low marsh is inundated every day with a high tide, and they provide different habitat for different creatures. There's one in particular, the salt marsh sparrow, that lays its nest, hatches its fledges its chicks all within that lunar cycle in the less than 1 month. So if we were to lose that and it would flood every day, then they would lose their habitat, and their numbers are declining by about 9% a year. So here's Pocha Pond currently. If you've ever been out here, this is on Chappaquiddick Island, Leland Beach near Norton, Leland Beach and Cape Hogue Wildlife Refuge. So behind this barrier beach salt marsh system, it's mostly high marsh right now. By 2030, you can start to see some of this teal color come in, and that is low marsh creeping in. We're already partway there. And then by 2050, the light blue is tidal flats. So these are transitioning to tidal flats. And then by 2070, much of the marsh is open water. Now here is the North Shore. So this is the Great Marsh up in the north. Great Marsh is 20,000 acres of salt marsh. It's the largest salt marsh in all of New England. Just incredible habitat, incredible carbon sequestration. This is a map right now. The lighter yellow color shows the high marsh, and then this teal color along the blue is the low marsh. Now I just jumped ahead to 2070 here, which is about when we see the large scale transition of high marsh to low marsh. So I'll do that again for effect. Yikes. We have also, the SLAM model also has mapped migration areas. So in red here, I've just zoomed into certain areas showing where the marsh may migrate. Those are areas that are great targets for us to prioritize for protection and restoration. In some cases, you'll see their forests, in some cases, their farms. But they don't equate the same amount of marsh that we expect to lose. We're hindered by the slope of the valley. Sorry, I have a little munchkin here asking for something. Here's salt marsh loss in, so our new report that we're working on is down on the south coast, Buzzards Bay. And I don't have beautiful maps yet for that. So I pulled this right off of the SLAM viewer, CZM SLAM viewer online. This shows an area zoomed in for Westport and Dartmouth down here. And the light, this is a less perfect legend over here. So the irregularly flooded marsh is this light green, that's the high marsh. And you'll see as I move forward to 2030, it's changing to this darker green. That's the low marsh. So here again, high marsh to low marsh. The beige color is tidal flats. It's becoming tidal flats. And by 2070, it's largely open water. These marshes down here in the South Coast are fringe marshes. They're much smaller than the Great Marsh. And so they're much more affected by sea level rise. And we're seeing close to 80%, here we go, 80% of high marsh lost in this region by 2050 is what the SLAM models are showing. So I wanted to show you our website. This is what it looks like if you want to go access this data, www.onthecoast.thetrustees.org. Now, this is going to pull in all the flood, erosion, slam data for the areas we've done reports, so the North Shore and the islands, and soon it will have the South Shore. But if you're interested in just looking at the slam data, the data I showed you, you can Google CZM slam modeling and go to the actual state's website, and you can see it for the entire coastline. Thank you to our sponsors, Remain Nantucket and Breckenridge Capital Advisors, for this last report. And here is my contact information. So I can open it up now for about 5 minutes of questions if we have time, Abby. I don't know how many participants we have. If we have any questions in the chat. I don't see any. If you didn't put one in the chat, you can go ahead and just ask it. Otherwise, I'll move on to Russ. All right. Again, please reach out to me if you have questions or if you have trouble accessing that data. I'm going to introduce Russ Hopping next, who is our lead coastal ecologist at the Trustees. He has a master's in environmental biology and has spent the last 30 or so years at the Trustees. He leads a team of ecologists that are both documenting and protecting rare species on our reservations, in particular shorebirds on our coast. And more recently, he's been leading all of our salt marsh restoration work. So Russ, pass it to you.
Well, thank you, Cynthia, and good morning, everyone. I can probably use the extra minute, so thank you. So anyways, I'm going to jump right into it. So Cynthia set me up.
I'm sorry.
That's fine. You can leave it there. Very well in terms of, I don't need to do a lot of the background in terms of the science, but I am going to be focusing on a project that we are phasing in on the Great Marsh up on the North Shore, using a couple of different nature-based techniques to essentially correct the hydrology of the marsh, which has been altered for a couple of centuries. So with that, if you can move to the next slide. So as Cynthia said, what can we do about it, right? That was the big question, and to some extent remains the big question in terms of salt marshes. But I need to take us back in time a little bit to explain why we're using certain techniques that I'm going to be talking about. And when we're talking about restoring the hydrology, the picture you see here is why we have to restore hydrology. Soon after the Europeans arrived in New England, they began to alter salt marshes wholesale. And this is a pretty good example that illustrates what they did. And what they were doing is they would build these embankments to literally keep the floodwaters of the daily tides out of vast areas, and then create a network of ditches and floodgates. You can see one of those here in this picture. There were various designs of these, but this is essentially what was done across all the marshes in New England. I think very few acres escaped, certainly in Massachusetts. So what did this vast alteration do? Well, we see a lot of the remnants today, all these straight lines going through our marshes. I grew up and understood until just recently those were done by mosquito control. Well, it turns out most of them were done long before that to increase agricultural productivity. So by creating all these ditches, and in this case, the picture you're looking at, again, is high marsh with the ditches very close together. What it ended up doing is drying out the marsh peat. And when that happens, it subsides. So it essentially sinks as a result of air getting into the peat, which is mostly undecomposed organic matter from the grasses that grow on the marsh. Once you let that air in, you start that decomposition process, and the whole marsh platform sinks. Next slide, please. The other trajectory, both of these lead to subsidence, so the marsh sinking, is when those ditches get clogged, the water stays on the marsh, and essentially what happens is the plants drown. These are, wetland plants, they're not aquatic plants. So in this picture, you can see an area that was, this is up in our phase 1 area up in Newbury. So this is literally the site that I'm going to be sharing a lot of data from. You see these pools already starting to form, and then I've outlined some areas where the grass is already dead. Those will become flooded, and this is how these areas increase in size, and we call these mega pools. So when the grass dies, because it does not want to grow in saturated soils or in water, we lose that biomass, the root mass, and the whole platform sinks again. So in both cases, this legacy of this agricultural use and the infrastructure that's still there is causing our salt marshes to subside. Wrong direction if we're thinking about sea level rise and the marsh needing to build. Next slide. So I'm going to be highlighting this. It's a phased project. It's about 1,300 acres. We're several years into it, and we have many years to go. But most of what I'm talking about is phase 1, and that's the 85 acres you see in blue at the top of that diagram or map on the left. Thank you. That's up in Newbury. That's our Old Town Hill site. And then phase 2 is in red, and then phase 3, which we're just beginning now, is in purple. Phase 2, we just started the salt marsh restoration work this winter, and you'll see some photos of that. Just want to highlight all, I call them our partners, but these are more than partners. These are our partners that are funding our work. Next slide. So this is what our primary restoration technique looks like. And this is a restoration plan for those 85 acres using ditch remediation. And I'm going to tell you what ditch remediation is in a minute here. But what you're looking at is the restoration plan. All these lines in red are the old embankments. Now, they're not as high as that painting that I showed you, but they may be just a few centimeters high, but they're still functioning to some extent by altering the hydrology. All the green and blue lines are the ditches that were created, and the green lines are those ditches that we're going to be remediating with ditch remediation. And then just want to draw your attention to the lower part of that restoration design. You see those yellow dots. Those are where the ditches have been clogged, and we need to remove those ditches to allow draining. Okay, next slide. So these are the tools for ditch remediation. Because this is a technique that we learned about from the U.S. Fish and Wildlife Service and UNH, where they had done some trials over at the Parker River National Wildlife Refuge on a smaller scale. We got very excited that, you know, this is all about restoring a natural process, that natural hydrology. And for us, it just, the light bulb went on, and we said, yeah, this is, if we're going to come up with something that can help us address landscape scale restoration, this seems like we're on the right track. So an automated process to some extent is what we need to scale up and do thousands of acres. So on the left, you see, that's a sickle bar mower. That's, you know, these are both small machines, walk behind oversized tires, no impact on the marsh whatsoever. So a ditch that we are looking to heal, and I want to stress this, this is not a fill. This is not a process to fill ditches. We're healing these ditches from the bottom up. And then, so the grass is cut, and then it becomes hay, and then the machine on the right is a little hay rake. And that just moves the cut hay into the ditch where it is secured with twine. Next slide. And this is the process we're trying to undo and essentially the end result. So again, this is healing the ditch from the bottom up. We're only doing about 50%. It depends on the marsh, but in general, 50% of the ditches, because we need to keep some of the ditches there to function as natural creeks would. But on the left, what you're seeing is a ditch that has not been remediated. It allows all that groundwater to drain out over the tidal cycle, exposing the peat to the air, and thus you get that decomposition. On the right, you'll see 3 different colors in the ditch. That's 3 years of treatment. We can't do this all in one year. It doesn't work. We need to work with nature. It's a little slower, and rebuild the peat from the bottom up. bring it to within about 20 centimeters of the surface, and we restore the groundwater so we don't get that oxidization anymore. And then we leave about 20 centimeters of the ditch, which is now able to vegetate. The alterniflora, this is the low marsh plant, is able to colonize. And by not bringing it up to the top, we avoid any waterlogging of the marsh. Next slide. So what you're seeing here is all of the purple lines are the ditches that were treated in 2020. So first year of ditch remediation, we did 83. Next slide. 59 the second year. So each year we do, it's a 3-year process. We do fewer and fewer ditches because we've succeeded in rebuilding a ditch. If it's not as deep, as some of the other ones, it may only need 1 year of treatment. Some may only need 2. We're anticipating only 3 years of treatment. So there should be many fewer than 59 this year, which is the last year of restoration. Next slide. And what you're looking at here is essentially a finished product. The ditch has been raised up almost to the surface, and now you see to the marsh plain, and now you see the alterniflora colonizing, growing in this ditch. At this point, we turn it over almost exclusively to nature and let nature do the rest of the job. All right, next slide. So the other technique that we're using, and Danielle's going to talk a lot more about this, is what we call runnel or micro runnels. So this is designed for our phase 2 in Essex, and I just want to draw your attention to this white circle at the bottom in the middle. You'll see within there a little orange line, that is the runnel, and then those orange dots, those are what we do with the excavated material, and we create micro topography, or in this case, we're calling them nesting islands. So this is the connection to the saltmarsh sparrow that Cynthia mentioned. All right, so next slide. So what runnels do is not all cases can we address the broken hydrology just through ditch remediation. So there are some areas that we're looking at that we just can't reach, but we need to remove some of this water. And in doing so, we're using these runnels. These are very shallow. These are 4 to 6 inches deep by up to 2 feet wide, and they're beveled on both sides. And you can see in this case that excavated material has been piled very carefully there in the center into a nesting island, so to speak. This will vegetate very quickly within 1 year. This was just done about 3 weeks ago. Next slide. And this is a diagram just explaining what we're trying to do. So in these areas that are waterlogged on the left, you see the groundwater is right at the surface, and it's saturating the roots, and or it could be a very shallow pool. Vegetation is declining. Ultimately, there'll be no vegetation there. And on the right, after a runnel has been installed, we've lowered that surface saturation, down 10, 20 centimeters. That's the root zone. And what it does is it reinvigorates any vegetation that's there and allows new vegetation to colonize. That's very important because 2 things. One, as I mentioned, up to 80% of the salt marsh peat is undecomposed organic matter. That's coming from the plants themselves. So this is the engine that's generating that material that helps build the peat. And then when the marsh does flood and bring sediment with it, the vegetation is needed to trap that sediment. So it's very important for those 2 reasons. Next slide. This is just an example of when the runnels were being created. This is the small excavator we use, and you can see it's on wetland mats. And it's just putting in wooden stakes into this clump of material so it doesn't wash away with the tides or with ice flows. Next slide. And then this is this is an image from the Parker River National Wildlife Refuge, where they did some of these nesting islands, and this is regrowth within one year. So these sites are not going to be unvegetated very long. Next slide. And then phase 3, just a close-up of that. Some of our partners are working with Essex County Greenbelt and the State Division of Fisheries and Wildlife. So almost 1,000 acres, and beginning to fill in some of the remaining spots in between phase 1 and phase 2. Again, goal, landscape scale restoration. Okay, next slide. So that's the background of why we chose these strategies, what we're trying to achieve by restoring the hydrology. And then because much of our work is a pilot or considered a pilot project because of its scale, these are the metrics that we are measuring. And I'm going to go through some of those and share some early results. So next slide. As you learned, salt marsh sparrows are one of our targets, conservation targets. So what we're doing is doing breeding bird surveys on all of this. So on all 1,300 acres, we have done breeding bird surveys, primarily to understand the density of salt marsh sparrows. So at phase one, this 85 acres, all those blue pins represent, on the left, those represent breeding bird survey points that we visit every 2 years. So 2 years ago, we had 35 salt marsh sparrows that we're going to be resurveying those same points again this year. On the right, even though it's not breeding birds, the salt marsh is important habitat and is mapped, designated priority habitat for terns, in this case, least terns. Part of our process is we monitor for tern use to understand where the terns may be using in those areas we would avoid during the restoration process while they're here. Our observations tell us they're mostly here in using the salt marsh in July. In this case, you can see no least terns were found at Old Town Hill, but on the adjacent marsh, we had up to 2 in that blue area. So just another factor that we're trying to document as we go through this process. Next slide. This was unintentional, but because of the mosquito monitoring that we do, which I'm going to talk about next, we're in a position to document salt marsh sparrow nests on some limited areas within our restoration work. And this is kind of exciting because those yellow dots you see on the left side, those were 4 salt marsh sparrow nests that were discovered in 2020. And then in 2021, we see those green dots. We found 4 salt marsh sparrow nests in an area that is waterlogged. So what's interesting about this is this was post 2 years restoration. So it's early, it's very early, and I don't want to draw any conclusions, but what we think we're seeing here, and there's some other indicators pointing in this direction as well, that the marsh is drying out, and as a result, we are anticipating salt marsh sparrows recolonizing this area, and we think that's hopeful. Obviously, we have to wait for this to become a trend. Just want to point out these dark areas in the marsh. That is where the water, the groundwater is saturated at the surface, and these mega pools are beginning to form. Next slide. So as I mentioned, we are monitoring mosquitoes as well. And this is important because nobody wants to see any restoration activity generate more salt marsh mosquitoes. If you've ever spent time in a salt marsh during mosquito season, you can understand why. So we partnered with Essex County Mosquito Control, and they are monitoring 30 acres at Old Town Hill and then at the other phase 2 sites as well. So it's a subset. They are using their method of monitoring mosquitoes, and it's more based on where is their habitat. Let's go and monitor how many larvae there are. We imposed on top of that a transect system. So it wasn't just where they're breeding now, but we wanted to document over the entire marsh that our restoration work was not going to transition marsh that's currently not mosquito habitat to mosquito breeding habitat. So I just want to point out, last year, we've been doing this for a couple of years now, but last year was very wet. It was a heavy precipitation year, and we saw slight increases in mosquito populations. But what's exciting, let's go to the next slide. And for anybody who's not familiar with how this is done, we use the dip cup. It's just a wooden stick with essentially a 1 cup plastic measuring cup on the end. It's a little nicer than that. And then you go to a site, if the site has any standing water, you take 3 dips to get a sense from 3 different, within a meter of if there's any larvae in there, that's what you count. So next slide. So using this method, what we were able to come up with is, so this, again, this is just from the Old Town Hill. We can see that the very first year, we had roughly 9% of the stations were dry. And this is all from the transect work. So essentially there was no water present to even use that dip cup. In 2021, 25% of those stations, even though it was a very heavy precipitation year, we had dry stations. So we're seeing the marsh platform dry out. It was statistically significant. What's really exciting is we were doing the same thing at the other sites in Ipswich and Essex. We saw no change there, but we had yet to do any restoration action. So at Old Town Hill, we're seeing 2 years of restoration, essentially indicating that the system is drying out. So it is doing what we anticipate. And this will, if you can move to the next slide. So another indicator. So some of the other things we're looking at is elevation. We want to know, is this marsh keeping pace with sea level rise? So we installed these SETs, these surface elevation tables. They can look at millimeters of change. And on this map, you can see where all those blue dots are the locations of these SETs. Very labor intensive, but what it is indicating to us already that the marsh is accreting material and gaining in elevation, essentially able to keep pace with current sea level rise around 4 millimeters a year. The table up on top is just indicating that we have a reference point. We have other tables within just where we're doing ditch remediation. And then the lowest line is where we're doing ditch remediation and removing those blockages. So you see in each intervention, so to speak, we have greater accretion and elevation gain. So perfect. This is exactly what we want to see. It's trending correctly. Next slide. Apologies for this right up front. I mean, this is a very busy slide, but essentially what you're looking at is 3 different areas where we contract this out to UNH. So they're collecting this data. 3 different areas within the marsh where they're collecting vegetation data. So the very first row is between ditches on the marsh platform. The middle row is at the ditch edge, and then the bottom row is in the ditches themselves. So it's very encouraging to see more blue, if you will. The blue is the Spartina patens. That's that quintessential high marsh plant. So we're seeing that increase, or other high marsh plants. We're seeing a decrease in the alterniflora. That is the low marsh. Again, we're in early stages, similar progress with the ditch edges, less so at this point within the bottom of the ditches, but that's to be expected because that's where we're expecting to do the heaviest lift in terms of restoration. Some ditches are going to take a little bit longer. Ultimately, we're expecting to see more alterniflora in the ditch bottoms. Next slide.
Russ, you're at 21 minutes. Sorry to interrupt.
Excellent. No, please. Thank you. That was very helpful. So this is where we're looking at where the waterlog trajectory was and occurring on those 30 acres. Just highlighting here that we're seeing across the whole marsh there a decline in alterniflora, which is super good news. So again, we're looking for high marsh plants, particularly patens, to begin to increase and seeing alterniflora decrease. We're seeing a more rapid change where we're able to remove these blockages, and that makes sense. So another indicator initially indicating it's moving, the system's moving in the right direction. Next slide. And then because we're looking at this over thousands of acres potentially, all that monitoring I just showed, it's really impractical to think about doing that on thousands of acres all the time. So this is a means of looking at unvegetated versus vegetated remotely. So thinking about, where there's water and mudflat versus where there's vegetation. We're waiting on the data from 2021, but what you're seeing here, at least for these 4 years, is you see each year is progressively getting essentially less vegetated. It's getting wetter. So this is what all the modeling is telling us as well. We expect to see in 2021 less red in this picture. So essentially it's a heat map. So where you see orange and red, it's getting wetter, there's less vegetation. So this is one of the techniques, the monitoring techniques we hope to use as we really scale up. Next slide. And perfect timing. So this is my last slide. So wrapping it up, as a result of really 1 year post baseline monitoring, we are beginning to see the hydrology change in a direction that we want it to. We are seeing sediment accumulate again essentially at the rate of sea level rise. That's good news. High marsh vegetation is gaining. Again, great news at the loss of Spartina alterniflora. And then we hope to see with the new remote data that our vegetated versus unvegetated is also, showing that the marsh is drying out and vegetation is increasing. So with that, I think that was my last slide. I did better than I thought.
If anybody else has questions, please go ahead and put them in the chat. We do have a question from Robin for Russ. And Robin asks, how do you identify the features that need to be addressed to restore the marsh? Do you use mapping tech, historic maps, on the ground observations, and that kind of thing?
All of that and more, really. So it's been certainly using historical photographs, we can see that the marsh is experiencing change. And what I mean by that is we're seeing a lot more standing water on the marsh and these mega pools growing. We've also done some of the initial investigations. We're looking at subsidence through oxidation. So looking, taking transects across the marsh, and we can literally see the subsidence basins around all those ditches that are continuing to function. There's no reason to think that that's not happening everywhere where we're seeing the marshes ditched. So there's that. And then going out on the marsh is critical. I would invite anybody, if they have an area of marsh that they're familiar with, to go look at that and just think about some of the changes that you're seeing. One of the best ways is just to start walking across a marsh, and you will very quickly realize how soupy some of the areas are becoming as it falls apart, as that groundwater increases and stays at the surface. And then looking at the vegetation, this image, the background image to my slide here, you see the high marsh, so the patens in the front, the four of that, and then behind it is this low form alterniflora. We are seeing hundreds of acres of this now, current conditions, and it is expanding. So this is the transition phase. So there's many indicators that we can look at, both through the historical photo and then what we're experiencing on the ground just by going out and looking at a marsh and mapping current conditions, that it's all indicating it's getting wetter and starting to fall apart. Hopefully that answers your question.
Where are you getting those historic photos from? Is that a public source, or what's your source for that?
Yeah, ironically, so the primary contractor that we work with to do our restoration plans, he uses just Google Maps, or I'm sorry, Google Earth. So you have that feature. I mean, it sounds, almost too simple, but you have that scale bar that you can go back in time, and that frequently is enough just to be able to show you. You kind of have to zoom in on an area, but then there's also, you can look at historical aerial photos. There's resources online for the online for those as well, but we have not found it necessary to really go beyond that to order any. It can be quite expensive to order historical photos or visit historical societies. We haven't found the need for that.
Great, thank you.
There's also, and sometimes there's some very good local knowledge. If you've got anybody that still does haying, salt marsh haying around, they can tell you how the marsh has changed quite a bit as well. Thank you.
All right, I'll go ahead and introduce our next speaker, who's Danielle Perry. She's the Coastal Resilience Program Director at Mass Audubon. She's guiding their climate resilience work there, including climate adaptation projects, and collaborates with partners, agencies, and towns to preserve our Massachusetts coastline. She has a background in salt marsh adaptation and leads Mass Audubon's salt marsh restoration efforts. And I think she's being a little bit humble. You have a PhD too, don't you, Danielle?
I do. Thanks.
All right, I'll turn it over to you. Oh, I'm going to stop sharing. You're going to do your own.
Thank you. Thanks, Cynthia, for that introduction. I'm just going to share my slide here. Okay. It should be in the right view, is it? Great, thank you.
Yeah, looks good.
Good morning, everybody. Thanks for joining on this Saturday morning. Before I go into my presentation, I wanted to speak a little bit more about Mass Audubon and Mass Audubon's mission. So Mass Audubon, it protects more than 38,000 acres of land throughout Massachusetts, saving birds and other wildlife. We welcome more than 500,000 visitors a year to our wildlife sanctuaries and 20 nature centers. Today, Mass Audubon is a nationally recognized environmental education leader, offering thousands of camps, schools, and adult programs that get kids and adults outdoors every year. We advocate on Beacon Hill and beyond and conduct conservation research to preserve Massachusetts land. And most recently, we sparked our coastal resilience program this past summer, where my position came from to be the coastal resilience program director, to further emphasize our need to protect our coasts. So since my previous presenters did such a great job giving background about sea level rise and the impact of sea level rise on the marshes, I'll just go through these intro slides a little quickly. So just to reiterate the urgency of thinking about New England and sea level rise, which is an area particularly vulnerable to the impacts of sea level rise, because we are seeing rates that are about 3 to 4 times the global average. And how this is impacting the marsh. So what you can see from the photos is this pooling that is happening that Russ had spoke on as well. And the pooling is killing off the vegetation, is likely to expand, creating mega pools and creating these mud flat areas. So we're seeing this increase in plant death, these increase in ponding and overall marsh erosion. So the natural response to the salt marshes is to move inland, to migrate inland. But because of coastal development, there's very few opportunities for marshes to do this. So marshes are basically drowning in place. They're basically being squeezed out by sea level rise and coastal development. And to further picture the impacts of sea level rise, this is a snapshot of the Great Marsh on the North Shore, the locations that Russ was speaking on for his presentation under current conditions of sea level rise. And this is what it's going to look like by 6 feet of sea level rise, which is expected to occur by 2100. So as you can see, that a lot of the Great Marsh areas are expected to be flooded, which makes the projects that Russ had discussed even more vitally important, so that we were able to protect these habitats and facilitate salt marsh migration. And so not only is salt marshes important for people for the reasons that were mentioned before, for important flood abatement purposes, storm surge mitigation, it also is important due to climate change. And as Cynthia mentioned in her presentation, that salt marshes are able to store more carbon per unit area than forests are. And this is just a graph that depicts that. So in this green cover, it shows the total land area, and in the darker green is the total carbon burial. So as you can see, salt marshes, they do take up a lot less area than forests do, but they're able to store a significantly more carbon due to the fact that these areas are very slow to decompose because of the lack of oxygen within these areas. And so which further emphasizes their importance to protect the areas that we do have of salt marshes because of these features of carbon sequestration and removing greenhouse gases from the atmosphere. We also want to protect salt marshes due to this little bird, salt marsh sparrows, and that nest and live exclusively within salt marsh habitats. And you can see this picture of the impacts of sea level rise on this bird species. And so with sea level rise, their nests are being flooded more frequently, which is causing this 9% decline every year in salt marsh sparrow habitat. And this bird is particularly of interest to U.S. Fish and Wildlife Service and Mass Audubon and others partnering with U.S. Fish and Wildlife Service to protect this bird through various salt marsh restoration efforts in order to prevent this bird from going extinct. So I'll speak about the vulnerability assessments that Mass Audubon has completed within its coastal sites to get a better idea of our current conditions of our salt marshes, as well as expected future impacts of our salt marshes and the actions that are needed to protect them. So Cynthia had mentioned this SLAM modeling, so the sea level affecting marshes model. And so we use this as part of our first phase of our assessment. And so similar to the photos that Cynthia showed for Allen's Pond, so I'm glad that I get to do a little deeper dive into Allen's Pond and the future impacts of this location that I'll go into those results in a little bit. But just to kind of go through the methods that we are using. So we look at intermediate high sea level rise scenario for the years of 2030 and 2050. So then we're looking at percent change in habitat. So each color within this map that you can see represents a different habitat cover. And I'll kind of, when I speak of the results, I'll go into which color represents which habitat. And so we really look specifically for this assessment at low marsh habitat, high marsh, transitional marsh, and tidal flats. And so we're looking at the years of 2030 to 2050 and noting the percent change in habitat from 2020 to 2030 and then 2020 to 2050 during these assessments to give us an idea of what we, without intervention, without restoration, how much loss or how much gain were expected during those timeframes. And then we go into field surveys of the salt marshes to get a better idea of the current salt marsh conditions, which will tell us more about the overall resilience of those salt marshes. So first, we will look at resilience. So we will have a resilience score for each of our coastal areas, and this will be ranked from very low to high. And this resilience score is looking at disturbance. So these are disturbances that are known to have adverse effects on the marsh. And so we look at the frequency of those disturbances. So the higher the disturbance within the marsh, the lower the resilience. And so we look at disturbances like nutrient input, ponding, plant die-off, ditching, invasive species presence. And then the next phase of these field assessments is looking at the overall salt marsh condition. So we're looking at the current conditions of the salt marshes and the vegetation that is currently inhabiting the marsh, as well as any bare areas or ponding as well that is occurring. So the higher the habitat quality is, the higher the salt marsh condition score, and the poorer the habitat quality is, the lower the salt marsh condition score. And that score is a max of 10. So 10 being salt marshes that have higher habitat quality, and salt marshes that have lower habitat quality, you'll see more of a lower score. And the last thing we look at is migration potential. So as I mentioned before, one of the natural responses of salt marshes is to migrate inland, is to be able to basically run away from sea level rise to create new habitat that is free of flooding stress. So being able to rank this from very low to high, we look at the natural environments or the developed environments around these salt marshes to get a better idea of overall migration potential. So if there's space for landward movement, it'll get a higher salt marsh migration potential. And if there's less space for movement, if it's more of a developed area like residential or urban, it'll get a lower space for land movement. And the lower the migration potential, we equate to being a little bit less resilient because it has less of that protective quality of migrating inland. And this method was based off of the Rhode Island rapid assessment method to analyze conditions of salt marshes. So now I'll do a deeper dive into Allen's Pond. So I'll speak about Allen's Pond specifically of some of the results of these vulnerability assessments. And just to speak a little bit more widely about the sanctuary itself, it's about 906-acre property, and it consists of about 130 acres of salt marsh. It's a designated important bird area and an important nesting site for salt marsh sparrows. And due to the rate of decline, every habitat is vital for salt marsh sparrow survival. So that's why we're giving current attention to Allen's Pond, because of the results I'm going to share with you now in order to protect this important marsh for salt marsh sparrows and other bird species. So I'll walk through each of those scores that I presented, that I showed the methods that we administered for each of these different steps for the vulnerability assessments. So first I'll talk about the habitat change. So how we use the sea level affecting marshes model and some of the effects that we're going to see in overall loss and some gains of habitat. So when we think about high marsh from 2020 to 2030 at Allen's Pond, we're expected to lose about 32% of our high marsh area. And our overall marsh area, so this is including with thinking about low marsh as well, is we're about to lose about 6% of our overall marsh within that area. And it's an important distinction to think about the difference between high marsh and low marsh because of those differences in utilization of wildlife species. So as mentioned before, salt marsh sparrows, they nest exclusively within high marsh areas. So the fact that we're losing 32% of our high marsh is very telling, even though we're only losing overall 6% of our marsh, because we're losing 32% of salt marsh sparrow habitat if we're not intervening and doing actions. And we're gaining about 13% tidal flat. So that's that mud flat area of having that effect of that pooling that is occurring, of just getting larger and larger and creating more tidal flat and creating more mud flat. So this is really, this increase in tidal flat is really a sign of degradation. So when I move over to the time frame of 2020 to 2050, we're expected to lose about 98% of our high marsh by this time at Allen's Pond. Again, very devastating to the salt marsh sparrow. And overall high marsh habitat is about 5%, losing 5%. And you can see that by 2050, we're actually, it shows a little less loss of habitat, and that is because of those transition zones. So we are gaining salt marsh, a bit of salt marsh because of salt marsh migration, which is a positive thing, which speaks to our moderately high migration potential, because Allen's Pond is surrounded by natural areas, natural forests, natural grasslands, providing habitat for marshes to move backwards and or to move more inland. So that's being represented by this little drop, 1% drop of gain of marsh during this time frame. But we are gaining greater than 100% tidal flat. So this is about 2.4 times more tidal flat than in 2020. And again, just showing another sign of this degradation that is occurring at this site is that we're losing marsh because of sea level rise. We're seeing these pools and ponds becoming larger and larger, creating this tidal flat area. And because photos, and this is all without intervention. So if we're not doing any restoration actions, if we kind of leave the marsh stagnant, are the losses and impacts and degradation signs that we're expected to see during these timeframes. And so I'll just show some photos of what this transition and change in habitat looks like. So the light green, which is right now the majority of the marsh, which is representative of 2020, this is low marsh habitat. And you can see pockets of the high marsh, the low green is high marsh habitat. And then you can see these smaller pockets of the darker green, which is low marsh habitat. And this light yellow here is tidal flat, and this bright yellow is oceans, but we'll focus less on the oceans. So again, this green here, this is high marsh habitat, and the darker green is low marsh. And that is you're gonna see the significant changes when I jump now to 2030, where we're seeing this darker green, the low marsh habitat, really taking over the high marsh area. So again, devastating to the salt marsh sparrow because they nest exclusively within that high marsh area. So it's losing its habitat. And those photos were from, you might have recognized them from Cynthia's presentation. These are all from the CZM SLAM modeling. So now I'll talk a little bit more about the resilience features. So this area and sanctuary is moderately resilient because of these different factors. So it is a low buffer encroachment. So as I mentioned before, it does have a little bit of a moderately high migration potential because it is surrounded by natural features. So because of that, it has low buffer encroachment. So there is that potential for salt marsh migration. And there's little to no fill on this marsh, another positive quality. It also has minimal evidence of edge erosion and also low crab burrow intensity. So those features are helping the marsh itself be resilient. But the issue itself is that we are seeing significant signs of degradation even currently at this stage. So some of the disturbance impacts, we have barriers like stone walls and tidal restrictions on the marsh. Ditching is apparent on the marsh, and Russ talked about some of the negative implications of ditching. We are seeing this ponding and die-off areas and soil disturbance and invasive species presence. So I'll just talk about some of the actions that can be done to counteract some of these disturbance impacts. So being able to have infrastructure removal and being able to remove infrastructure, this further increases its ability to migrate. So being able to remove those stone walls, being able to remove those tidal restrictions really heightens its ability to migrate inland and to escape the stress of sea level rise. So being able to unclog some of those ditches that are essential for drainage, and also playing note and having an impact of creating that pooling. So certain ditches that are clogged, they help to trap even more water on the marsh. So being able to unclog those ditches to allow for drainage to prevent any excess water being stored on the marsh is helpful. And then this technique of runnels that Russ spoke of previously as well. So using these runnels on these shallow channels to drain those water impoundments, to drain those pools, to alleviate that flooding stress, to promote vegetation recolonization. And later I'll talk about some of the results of the runnels. And runnels are also important to controlling Phragmites as well, because Phragmites, they like a little bit fresher water, so they like being, and they can thrive in standing water. So runnels help to drain that standing water that Phragmites likes to live in, and then that helps to control the Phragmites within those areas. So these runnels can also be important for controlling Phragmites populations as well. So as you can see, the Allen's Pond is shown to be a high priority for us because of its current conditions, because of these impacts that we're expected to see over time without intervention. So thankfully, Mass Audubon with partners received a SNEP award as Southeast New England program watershed grant back in 2020 to do exactly that, to help to restore Allen's Pond, to help to build the resilience of Allen's Pond. So we're not seeing those high increases in tidal flats and mud flats, and protecting more of our high marsh and overall marsh areas. So this is just a number of partners that are involved within this project. And just to speak about some of the actions that we're doing. And so focusing on these climate adaptation projects. So removing some of the stone walls that you can see from these photos to allow the marsh to migrate backwards. We're doing invasive species control, as I mentioned, using that runneling technique. We're implementing runnels to drain water impoundments and pools, as you can see here. And also creating those microtopography habitats that Russ explained earlier as well. And just wanting to also create avenues of education and engagement. So we're being able to take people to the sites to see the restoration site. We haven't implemented runnels yet. We will be implementing runnels within the next few weeks. So come visit us to see the site. And also bringing people to tour the site as well. And so I'll speak a bit more about the impacts of runnels. So as I mentioned, we haven't implemented runnels yet at Allen's Pond, but this is a type of technique that has been implemented elsewhere. So Russ talked about how it's been implemented on the North Shore in the Great Marsh. This also has been implemented a lot within Rhode Island. So my background in my graduate time was in Rhode Island. So my previous work with runnels has been within that state. And so what you can see here is just examples of how runnels are created. They can be dug by hand using volunteers with shovels. If in certain situations, you can even dig a runnel with the heel of your boot. And again, just showing what a finished runnel looks like, this shallow channel that is just strategically placed to drain these pools and water impoundments. And this is just an impact of runnels that you can see. So this pooling that you see initially, we use an excavator in this case to create runnels. And this is about 2 years after the runnel was created, the amount of vegetation that has grown back. You no longer see those water impoundments and those pools occurring. And you also even see a dieback in the Phragmites that you see from the previous photo as well. And so as I mentioned, my original work with runnels has been in Rhode Island, and we were able to publish a study on the results of a runnel project that we had worked on. So I'll walk you through this graph. So this graph just shows the control. So the control is just what the runnels were before any restoration. It was basically the overall control area that was not impacted by restoration. The pre-restoration is the runnel areas that were before restoration had occurred. So specifically the runnel areas before any restoration happened at those locations. The reference, it represents, I'm saying this in air quotes, I'm a healthy marsh. It's because I'm saying in air quotes because it's hard to find a healthy marsh these days, but as close as we can get it just to see what we might expect or would want the marsh to look like. And for our runnel treatments, we split them into 2 separate treatments. So we had runnels in a low elevated marsh area as well as runnels in a high elevated marsh area, because the vegetation response in these different areas would be very different. So we wanted to make that distinction to see the impacts. So Spartina alterniflora or cordgrass is a low marsh plant species. So I'll focus on this for this particular graph of in the low elevation runnel, because this is where we're going to expect to see the biggest difference in vegetation response for cordgrass in this low elevation runnel, because that's the dominant plant species. And so for this particular study, it took about 3 years after the runnels were implemented before we really saw that impact of the runnels in this positive vegetation response. So in this light gray, I'll just draw your attention to the low elevation runnel. And even from October 2017 and to August 2018, October 2018, this large increase in vegetation. So again, the runnels were instituted back in 2015. And so about 3 years later, that's when we started to see this rapid increase in vegetation. So that really attests to the fact that depending on the degradation of the marsh, will have a large impact on how quickly the vegetation comes back as well. And I'll show some photos of a quicker response time to vegetation. But this marsh was previously very degraded, so it would take a little bit longer for the vegetation to come back. But the results are still clear that after these runnel impacts, we're seeing such a high increase to the point where it's comparison to this reference marsh of where we ideal conditions of the marsh that we want to see. So there's runnels having that positive impact and being very similar to what we expect and want to see within the low marsh when it comes to vegetation cover. And the same goes for 2019. We're still seeing that continued increase as well, and even surpassing the reference marsh, so even having better conditions to an area that is a little bit in better condition, previously was in better condition. So now I'll jump over to impacts of Spartina patens, which is salt marsh hay, which is a dominant high marsh plant material. So I'll focus on the results of the high elevation marsh. So this is where we expect that Spartina patens will dominate, because this is where it grows. And this also shows us the impacts for the salt marsh sparrow, because they nest exclusively within these types of habitats. So, and again, this is in 2014 representing previous conditions before restoration that took place. And by 2017, 2018, and 2019, this overall growth within of salt marsh hay vegetation after the runnels were implemented in this high elevation runnel. So we don't expect to see patens in the low elevation runnel, because that's just not the habitat for salt marsh hay, but we are very excited to see that this increase in patens over time with runnel, due to the runnel impacts. And you can see down here, the reference marsh having significantly less paten coverage, and to the point where we're seeing very low paten coverage at this time of 2019. So just seeing that runnel impact of being able to promote high marsh plant material, which is again is vital to the progression and the survival of salt marsh sparrows. So another positive impact of the runnels being able to promote that type of plant material. So if you want to read a little bit more about this project, it's published in Restoration Ecology. Feel free to do a little search and to find the article to learn about it in a little bit more detail. But oftentimes, because runnel pictures show a little bit quicker or faster story than graphs do, just wanting to show, this is just a project that occurred in Little Bay and Fairhaven. So this is a Massachusetts project from Buzzards Bay Coalition. And this showed a faster vegetation response than the Rhode Island study that I previously talked about. So this is before in November 2020, this is September 2021, and you can just see the amount of vegetation cover that has occurred, the decrease in ponding and pooling that has happened, and the positive vegetation response and the vegetation growing back. Again, what we would like to see with these runnels to be able to protect and keep this high marsh plant material. And so micro islands or micro topography is another action that we're implementing at Allen's Pond 2. And this is really in order to positively use the excavated material that was removed to create the runnel and use it for a positive purpose. So micro topography or micro islands is created by using the excavated peat from runnel formation to create higher elevation marsh areas. And the peat is removed to create the runnel, is placed into a mound on the marsh surface to create these higher elevated areas. And by creating these peat islands or these micro islands, we will use the excavated peat of the runnels in a way that not only avoids negative impacts, but will actually have a positive effect on the local ecosystems. So these islands have shown to reduce or halt marsh subsidence, and as a creation allows for areas for salt marsh sparrows to nest that is free of flooding stress. So these are just some photos that are representing when the peat island was created. So these are again mounds of higher elevated marsh locations. And then after just 1 year, the amount of vegetation that came back. And then by, or even after one growing season, not even one full year, just one growing season. And then after 1 year, you can no longer even see the bare areas and the amount of vegetation that has revegetated. So again, being able to find ways and positive ways to help create habitat for salt marsh sparrows, as well as being able to use that sediment that is being excavated to create the runnels in a positive manner to help wildlife. So wanting to kind of take a step back and talk more broadly about the overall salt marsh restoration community and how this is really a partnership. So Mass Audubon, the trustees, were even working with a larger network to enhance coastal resiliency, to prevent loss of community protection, and to preserve and restore ecosystem services and protect the 45,000 acres of salt marsh that Massachusetts has. And to prevent loss of salt marsh sparrows to be able to protect their habitat and to meet overall climate goals. And so this is really a larger group. So we have working with the U.S. Fish and Wildlife Service, Mass Wildlife, Greenbelt, all working toward this effort to help protect the marshes, and many more partners, University of New Hampshire, many more partners, to just protect the marshes within Massachusetts, because it is vital for not only humans, again, for serving those important purposes of storm protection, of flood abatement, to protect our homes and the buildings that we care about, but also for our wildlife like the salt marsh sparrows, and also to help us mitigate the impacts of climate change. So further emphasizing the urgent need, because we are expected to see those impacts of loss with sea level rise sooner rather than later. So just further emphasizing the need for action and restoration initiatives right now so that we can protect these habitats. And so with that, I will take any questions. And that's my contact information down here at the bottom.
So feel free to put your questions in the chat for Danielle. I actually have a question while we're waiting for that. I'm curious how it is permitting these projects, and if that process has changed over the last 10 or 15 years or so, where the regulations are often inclined to not impact the resource, right? There's a prevention of impact. And so how has that process changed, if at all, and have regulators been able to shift to kind of this more climate adaptation type of approach?
That's a great question. And Russ, feel free to jump in as well. So permitting for these projects right now is a barrier. So it has shown to unfortunately delay some of these projects too, but we're currently working with regulators, trying to get them more comfortable with these techniques, kind of showing them the data that shows these positive impacts that we're seeing, and really highlighting the urgency to implement. And so that we're able to do more of these projects at a larger scale so that we can protect more salt marsh habitats. But right now, it's a barrier, and it's a barrier to having these projects move a little bit forward. But we are collaborating with permitters to help ease that barrier to allow these projects to continue.
Yeah, I would just echo that. I think we're trying to do almost a true track system right now. So where we have some of these pilot projects, which we were able to get fully permitted, the next phase of those, we're in the process of working with the regulators to understand how we can continue that momentum, but then a separate track, long-term understanding how some of this resiliency work and habitat restoration work can get streamlined through the current permitting system. There's probably no greater natural resource that is more regulated in Massachusetts than salt marsh, and for good reason. But this is something that was never anticipated. It does require some creative thinking and maybe, reworking some of the existing regulations. So we're on it. We're hopeful hopeful that some of these changes can happen in a timely manner so that we can continue this scaling up around the state.